the next primitive data type, which happens to be the character data type. On a personal note, this happens to be my favorite data type. It is because in this particular data type, we are going to understand from the scratch as to how binary code, the binary values would be assigned to different characters, because we understand something very fundamental about the computer's memory, which is in the memory, the data would always be stored in the binary format. Anyways, let us proceed with the discussion. Let us assume in this entire real world, we had only two letters, only two characters. What those two symbols are, sir? Maybe I would assume those two characters are going to be A and B like this. And maybe then we were assigned with the job of assigning a unique binary code to each of these two symbols. And can you tell me, in that binary code, what are the only two symbols I'm supposed to use there? Obviously, binary means only two digits that are permitted here are 0 and 1. Hence, I would go ahead and very smartly to the first symbol A, I would assign the binary code as 0. And to the second symbol B, I would assign the binary code as 1. Great, the job is done. Next what, sir? Maybe in the second case study, I have decided to slightly enhance the complexity here and increase the number of symbols in the character set. Maybe this time we would assume in the entire world, there were not only two symbols, maybe there were 4 characters like this. And once again, the job remains the same. Our job is to assign a unique binary code to each of these 4 symbols. Just think about it. If to the first symbol, I assign the binary code as 0. If to the second symbol, I assign the binary code as 1. Do I have any other options? Am I left with any other binary digits? So that I'll be able to assign the binary codes to the remaining 2 symbols here? 100% it is not possible. Oh, you're absolutely right, sir. Then how do we tackle this situation? It is very simple. Whenever the number of symbols in the character set would increase, it would demand from you that you will have to increase the length of the binary code. That means if you stick on to 1-bit binary code, definitely it is not possible for you to assign unique binary codes to all of the 4 symbols here. Then what do we have to do, sir? Like I said, increase the length of the binary code. Maybe to the first symbol, we are going to assign the binary code as 00. Of course, it is a binary code because it is composed of binary digits. To the second symbol, I would assign the binary code as 01. To the third symbol, 10. To the fourth symbol, 11 like this. I'm sure now all of you have understood what I meant by increase the length of the binary code. And this is similar to the concept of truth tables. I'm sure all of you have come across it in your academics. Now, let us proceed to the next case, where this time I have realized that only 4 symbols are not going to be enough. I will have to increase the number of characters in the character set in total to 8 symbols like this. And once again, the job here remains the same, that we will have to assign unique binary code to each of these 8 symbols. Please think about it. If I would restrict myself only to a 2-bit binary code, can you tell me how many symbols I will be able to handle? Only 4 symbols. After the 4th symbol, I would run out of all of the permutations and combinations. 100% I wouldn't be able to assign the binary code to remaining 4 symbols here. If I have to handle all of the 8 symbols here, definitely I have to increase the length of the binary code. And hence, for the first symbol, this is going to be the binary code. Next, for the second symbol, and so on. This is how the binary sequences would look like. Now let us say in the next case, I have decided this time I don't want just 8 symbols. I would like to increase the number of characters in the character set to in total 16 characters like this. And once again, I would like to assign the binary code to each of these 16 symbols. In which case, I don't think so. I'll have to once again ask, what should be the length of the binary code? Very good. This time the length of the binary code has to be a 4-bit binary code like this. Great, sir. But through this analysis here, what are we trying to generalize here? What am I trying to generalize here is a simple fact, which is as in when the number of symbols in the character set would increase, 100% the length of the binary code would also increase. This is a simple fact that I'm trying to build here. Also, I would try to derive an equation around the number of symbols and the length of the binary code. 100% there is going to be some sort of correlation here. Because tomorrow, if I would just randomly give you the number of symbols, you should be in a state to tell me what should be the length of the binary code in order to handle all of those many symbols. Anyways, before which, please understand whatever activity that we have done here, this is what is technically referred to as character encoding, assigning binary sequences to the symbols. Now let us proceed and derive the equation here. Let us get back to the first case here. Can you tell me in the first case, how many characters, how many symbols do we have? Very good, just 2 symbols. And that number 2, can I also express it as 2 to the power of 1? Yes, because any number raised to the power of 1 is going to be the same number. And please understand, whatever you see in the power of 2 there, that is what is going to determine the length of the binary code. And in this case, what do we have as the power of 2? 1. Don't you think in the first case, that was the length of the binary code? In other words, it was a 1-bit binary code. Similarly, in the second case, can you tell me how many symbols we have got? Absolutely correct. We have got 4 symbols. And that 4, I would like to express it as 2 to the power of 2 like this. And whatever is there in the power, that is going to determine the length of the binary code. 100% it is going to be a 2-bit binary code, for which already we have the evidence because we have completed the analysis here. Let us move on to the third case here. Can you tell me how many symbols? 8 symbols. And this 8, I would express it as 2 to the power of 3. Clearly, it has to be a 3-bit binary code. And in the last case, since we have got 16 symbols here, that 16, I would express it as 2 to the power of 4. It indicates it has to be a 4-bit long binary code. This is amazing, sir. But can you please tell us in total how many characters or symbols a computer is supposed to understand so that it knows what the binary equivalent is going to be, and hence it can store it in the memory? Do not worry about it. That job was already done long back, even before all of us were born, in the decade of 1960s. By a very famous organization just like IEEE. It is called as ANSI, American National Standards Institute. And they decided that in total, any computer should be able to understand a minimum of 128 symbols. And they were also successful in terms of assigning unique binary sequences to all of those 128 symbols. And that character encoding format, my friends, that is what is very famously and popularly referred to as ASCII format, American Standard Code for Information Interchange. And can you please tell me in the ASCII format, how many symbols are going to be supported? 128 symbols. And now you realize what you have just now mastered it. In fact, without even knowing what those 128 symbols are, all of my students now are going to be capable of telling me what should be the length of the binary code in order to assign binary sequences to all of those 128 symbols. That is the reason why all of this case study was done previously. Can you tell me what should be the length of the binary code? Very simple. First and foremost, this 128 has to be expressed as a power of 2 like this. It is nothing but 2 to the power of 7. And I have told you, whatever you have it in the power, that is going to indicate the length of the binary code. And ASCII happens to be a 7-bit binary code that is going to be assigned for 128 symbols. I'm sure all of you are now eagerly waiting to see what those 128 symbols are, sir, in the ASCII format. Don't worry, that is what I would be displaying now. This happens to be the beautiful ASCII table. And if I would scroll down, you would be able to notice all of the 128 symbols of the ASCII format. I know some of you whose eyes have already fallen into the last symbol, you would assume that there are only 127 symbols. Please understand, the numbering in the ASCII format has started from 0. So 0 to 127 means clearly there are going to be 128 symbols in the ASCII table. The very first symbol happens to be some null character. Then you have start of heading. Then we have start of text. Basically, all of these are control characters. And here, if you notice, in fact, whatever space that you're going to key in within your text using the space bar, that white space is also going to be considered as a character in the ASCII format. Next, we have got the exclamation mark here. We have got the double quote symbol here, the hash symbol, the pound symbol, dollar. Like this, all of these symbols are also going to be considered as characters. In fact, you have these digits 0 to 9 also. If you would like to consider them as characters, congratulations, the support is provided through the ASCII format. And finally, after a few other symbols, we have all of the 26 English alphabets here in the uppercase. All of these are capital English alphabets. Next, once again, after a few other symbols, we have all of the lowercase English alphabets here, and once again followed by some other characters. So all of these are 128 symbols of the ASCII encoding format. I also understand there is one thing that is bothering my learners here after looking at the ASCII table, which is, sir, you said in the ASCII format, for all of these 128 symbols, there would be binary codes that would be assigned. We are not able to see any binary code, sir. In fact, we are able to see decimal numbers from 0 to 127. Please understand, that is the call which the developer of this website has taken. He understands that it is going to be human beings who would come and visit this particular web page, and we human beings are not comfortable understanding binary numbers. Same binary numbers he has represented in the decimal format. That is all he has done.